Hey kids, this is Mr. Cozy, and we are talking about solving systems of inequalities in video 24. So we will start out by talking about what a solution to a system of inequalities is. We will then review how to graph inequalities, because the main method that we will use to solve systems of inequalities is graphing. And in the course of reviewing how to graph inequalities, we will review how to graph lines. So let's get started. A system of inequalities is two inequalities or more, and we want to find a combination of x and y value that work in both inequalities. For instance, if x were 6 and y were 2, this would work in both inequalities, and you can check that yourself just by subbing in. If x is 6 and y is 2, this makes 8, which is greater than 6, and this would make 12 minus 2, which is 10, which is greater than 1. So 6, 2 is a solution to this system of inequalities. So is 5, 3. Now here's the key difference between solutions to systems of equations and solutions to systems of inequalities. In a system of equations, there's usually only one x and y value that work in both. Sometimes there are infinitely many, but all of those solutions fall along a line. In a system of inequalities, more often than not, there are infinitely many solutions. There's a ton of points that we could use that work in both inequalities. And more importantly, all of these solutions fall within some region on the coordinate plane, so that if we picked any point in the solution region, we would have an x and y value that works in both inequalities. And if we picked a point outside of the region, we would have an x and y value that wouldn't work in at least one of the inequalities. Okay? So when we talk about solving a system of inequalities, I want to find the region that contains all of the x and y value pairs that work in both inequalities. Now, to find that region, I simply have to graph each inequality and see where the overlap is. So let's review graphing in inequalities. In particular, let's graph this inequality. So let's graph 2x minus y is greater than 1. Okay? Now, my first step is to pretend like this is an equation. I'm going to pretend that there is an equal sign here. There we go. And I'm going to graph this out as a line. So let's review how to graph lines. The first thing that you want to do when you graph a line is to put it in slope-intercept form, meaning that you get the y variable alone. You solve for y. So here we go. Minus 2x, minus 2x. I'm solving for y. And I'm going to have, oops, I had a, let me fix this here. Okay. I have negative y is greater than negative 2x plus 1. I'm then going to multiply each side with negative 1. On the left side, I'm going to have positive y, On the right side, I'm going to have positive 2x minus 1. All of the signs will flip-flop. And because I multiplied each side of this inequality with a negative number, the inequality changes direction so that I have y is less than 2x minus 1. Okay? Now remember that I'm pretending like this is an equation. And if this were an equation, then this line would be in slope-intercept form, where 2 over 1 is my slope, and negative 1 is my y-intercept. So let's make a coordinate plane, and let's graph this out as a line. Dagnabbit. Try that again. Boop. There we go. So, I'm not using this program again. There we go. Okay, here we go. My y-intercept is negative 1. My slope is 2, or 2 over 1. So I'm going to go up 2 over 1, plot a point, up 2 over 1, plot a point, up 2 over 1, plot a point, get a few points. And now, if this were an equation and I were graphing a line, I would just connect these with a line. Okay? And that's actually what I do if my inequality is less than or equal to, or greater than or equal to. If my inequality has an or equal to in it, I connect these dots with a line. Because this is strictly less than, if it's strictly less than or strictly greater than, I still connect the dots, but I use a dotted line. And I'll explain why I use a dotted line in a moment. But I use a dotted line to connect the dots. This got a little wonky here. There we go. Okay. Now, this line divides my coordinate plane into two regions. On one side of this line, all of the solutions to this inequality sit. On the other side of the line, none of these solutions to this inequality sit. So to figure out which side of this line has all of these solutions to this inequality, I simply choose a point on the line. I choose some point not on the line. And I chose 0, 0 because 0, 0 is a great point. X is 0 and y is 0. That's really easy to plug in. Now here's my thinking. I'm going to plug in 0 and 0 into this inequality. When I do that, one of two things will happen. Either plugging in 0 for x and 0 for y will leave me with a true statement, meaning that this point is a solution to this inequality, meaning that all of the points on this side of the line are solutions to this inequality. Or I plug in 0, 0 and I get a false statement, which is actually what happens here. 0 is not less than negative 1. This is false. That means that 0, 0 and all of the other points on this side of the line are not solutions to this inequality. All of the solutions are on the other side. Okay, so I shade the other side of the coordinate plane because I tried a point on this side and it didn't work out. So all of these solutions have to be on the other side. This line then is the dividing region between the side of the coordinate plane that have all of the solutions to this inequality and the side that doesn't. Now, along this line, if I plugged in any x or y value from this line, what I would end up with is something where the left side of the inequality equaled the right side. And if my inequality is less than or equal to or greater than or equal to, then that's okay. And I would use a solid line. I would use a solid line. Because this is strictly less than, the left and right sides here are not allowed to be equal. But I still need to see the dividing line between these two regions. And so I use a dotted line so that I can see the line, but that I know that none of the points along the line are solutions. Instead, all of the points on the right side of the line are solutions. Okay? So that's how you graph an inequality. Graph the line, test a point, and depending on how that test goes, you shade one side of the line or the other. Now, to solve a system of inequalities, you simply graph each inequality, and whatever region was shaded twice, that's your solution region. We'll talk more about that tomorrow. I think I've thrown enough at you today. Have a great day, and I'll see you later. Bye.